Welcome to this explainer. Today, we're unpacking the massive, heavy, physical reality behind the AI tools we're all using every single day. You know, when we interact with AI, it's so easy to think of it as just magic, right? Just weightless code floating out there in the cloud. But the truth is entirely different. We're going to look at the foundational, real-world structures being built literally right now to support the future of tech and the absolute staggering scale of the money involved.
$800 billion. Let that sink in for a second. We are currently right in the middle of an unprecedented $800 billion supercycle of capital expenditure, all dedicated to AI infrastructure. And when we say CapEx, we mean the hard cash companies spend to buy, maintain, or upgrade fixed, physical assets. The biggest tech giants on the planet are completely pivoting. They're redirecting historic amounts of their budgets away from traditional stuff like office spaces or standard software, and they're funneling it straight into this astronomical $800 billion surge. So you gotta ask yourself, where exactly is all this money going? Seriously, how do you actually spend $800 billion on something that feels entirely digital? Well, the answer is heavy, industrial expansion. It takes an insane amount of physical machinery to keep these systems running. To wrap our heads around this, let's quickly define what a supercycle actually is. We're talking about a specific period where incredibly high demand for an asset creates a multi-year wave of intense economic activity and investment. This isn't just a passing fad or, a single quarter of strong earnings. No, this is a massive, multi-year global shift in how resources are being allocated. And it's entirely focused on pouring money into hard, tangible, physical assets rather than just software development.
Section 1. The physical reality. Building for AI.
Okay, so this massive pile of money essentially buys three physical things. Step 1, securing high-performance computer chips. We're talking about GPUs and TPUs. These are basically the brains you absolutely need to train massive AI models. Step 2 is building the highly specialized servers to actually house and connect all those processors. And finally, Step 3 is constructing the massive data center warehouses to run the whole operation. You need enormous physical spaces with wild power and cooling systems just to handle millions of users at the exact same time.
What this means on the ground is a total infrastructure modernization. Companies are quite literally ripping out older general-purpose computer servers and replacing them with hardware designed strictly for AI tasks. It's a complete hardware swap happening on a global scale. They're prioritizing systems built specifically for the complex math that artificial intelligence needs, way over standard everyday computing.
Section 2. The hyperscaler arms race. Competitive panic.
So, let's break down the ecosystem. You've got the hyperscalers, companies like Microsoft, Google, Amazon, and Meta. They are the primary buyers here. They're buying up processors from chip manufacturers like NVIDIA and AMD. But it doesn't stop there. They have to rely on specialized real estate firms to build the actual data centers, and then, crucially, power utilities and grid operators to supply the downright enormous amount of electricity required. It's this whole interconnected supply chain, and it is running in absolute overdrive. And the timeline for this is wild. Because these sprawling data centers take anywhere from 18 to 36 months just to build, the hyperscalers have to spend their money today. The orders are being placed right now, which is going to trigger a massive construction phase peaking right around 2026. All of this is just to ensure they have the physical capacity, fully ready to deploy AI services by 2027 and 2028. They are literally building the future, years in advance. But the real kicker here is the scale. Hyperscalers are allocating up to 90% of their operating cash flow just to fund this AI infrastructure. Up to 90%. Let that sink in. Nearly all of the massive profits these global tech giants are making are being instantly funneled right back out the door to buy chips, servers, and real estate.
They are fully embracing a build-it-and-they-will-come mentality. They're pre-ordering huge amounts of chips, like NVIDIA's new Blackwell architecture, years before the final AI software is even finished. And why? Pure, intense, competitive panic. If one company blinks, if they stop spending, they risk losing the ability to host the next generation of AI, and that effectively hands the entire market over to their rivals. They are absolutely terrified of being left behind.
Section 3. Real-world impacts. Physical effects.
All this spending triggers a massive domino effect in the real world. First off, chip makers and server manufacturers are pulling in absolute record revenues. Second, we're seeing a global boom in physical data center construction. That means skyrocketing demand for raw materials like steel, concrete, and highly specialized cooling equipment. And third, Well, all these new facilities require immense amounts of electricity, which is putting unprecedented strain on power grids and even causing electricity costs to soar in certain regions.
Actually, because of this massive power draw, real estate decisions in tech have completely flipped. Historically, you'd build a data center close to where your users lived, right? To reduce lag. Not anymore. Now, it's all about energy-first decisions. Companies are plunking down multi-billion-dollar data centers wherever they can secure access to high-voltage power lines or private energy sources like nuclear and solar. They are totally ignoring where the actual users are and just chasing the electricity.
So what does this actually mean for us? Well, first, you're going to experience significantly smarter, much faster AI tools that can reason, see, and interact more like a human, basically just because there's so much more raw computing power behind them. Second, you'll probably notice the stock market becoming incredibly concentrated, with a huge chunk of value tied to just a handful of companies building all this infrastructure out. And finally, we're seeing a huge surge in job demand for roles you might not immediately connect to AI, like electrical engineers, data center technicians, and power grid specialists.
Section 4. The Precipice. Looming Risks.
Now, it's not all smooth sailing. There are some massive risks looming on the precipice of the supercycle. We've got to think about the environmental impact. The sheer energy and water used by these facilities creates a very real, significant carbon footprint. Then, there's the terrifying risk of hardware obsolescence. Because AI tech is advancing so incredibly fast, a $100 million computer system bought in 2026 could literally become completely outdated and obsolete by 2028.
But honestly, the most glaring financial risk here is the ROI gap, the return on investment. These tech giants are effectively spending $800 billion on physical hardware right now, but there's absolutely zero guarantee that they'll make that money back through ultimate software sales or user subscriptions. It's a historic, multi-billion-dollar gamble, all based on the hope that the software revenue is eventually going to catch up to these massive hardware costs.
Which brings us to the ultimate bottleneck, and what I want to leave you with today, the absolute biggest threat to this entire infrastructure build-out. It's not a lack of money, it's not a lack of silicon, it's a lack of electricity. The strain on our utility grids is very, very real. So think about this. What happens if the world simply runs out of electricity before these machines even finish learning?